Good morning, students. I'm Sangeeta, lecturer in chemistry, branch general section, Institute SSGPT, Jahirabad, semester 1, subject general engineering chemistry, subject code SC104. Our topic is electrochemistry. Major topic is electrochemistry. Duration 30 minutes. Today's topic is electrolysis of aqueous NaCl, teaching aids, PPT, animations, diagrams wherever required. Collect what we have discussed in last class. So what we have discussed in last class? We have discussed electrolysis of fused NaCl. So what are the products formed during electrolysis of fused NaCl? Once again, I will revise this electrolysis of fused NaCl. So today's our topic is electrolysis of aqueous NaCl. So to differentiate between these two, so once again I will discuss this electrolysis of fused NaCl, what we have discussed in the last class. So we are taking fused, that is molten or fused NaCl in the cell. Okay. So here two electrodes. These are connected to the two poles of the battery. So this is connected to the positive pole of the battery. So this is anode. This is connected to the negative pole of the battery. This is cathode. So when you pass electricity onto this electrolytic solution, that means fused NaCl, so whatever the ions present in the solution, so here they will move to their respective electrodes. This cation Na plus ion will go to the cathode and this Cl minus ion will go to the anode. So here this is anode, this is cathode. So this Cl minus, after going to the anode, it undergoes oxidation. That means it releases its electrons and forms chlorine gas. So whatever the electrons released here, they will flow towards the cathode. So their cathode, so what are the ions going? Na plus ions. These Na plus ions will takes these electrons and converts into sodium metal. So here at cathode, sodium metal is deposited. At anode, chlorine gas is liberated. So when you do electrolysis of fused NaCl, at anode, chlorine gas is liberated. At cathode, sodium metal is deposited. Okay, this is about electrolysis of fused NaCl. So today's topic is electrolysis of aqueous NaCl. What are the objectives? After finishing this period, you would able to understand this electrolysis of aqueous NaCl. So our topic is electrolysis of aqueous NaCl. So what is the meaning of aqueous NaCl? So here water, NaCl dissolved in water, that is NaCl solution. So we are doing the electrolysis of aqueous NaCl. So here first, so to do electrolysis, what we need? We need electrolytic cell. Okay. So in that cell, what we are taking? Aqueous NaCl as electrolyte. Then two rods are dipped and these two rods are connected to the two poles of the battery. Same explanation you have to give. So the rod which is connected to the positive pole of the battery is called anode. The rod which is connected to the negative pole of the battery is called cathode. Then what happens? Electricity will pass into the solution. So when electricity passes, whatever the ions present in the solution, they will move towards respective electrodes. After moving to the respective electrodes, chemical reactions takes place. So what are the chemical reactions takes place at anode and cathode? Always at anode, oxidation takes place. always at cathode reduction will take place. So what is happening when you do electrolysis of aqueous NaCl? We will see here. So aqueous NaCl contains what? So first, aqueous NaCl contain H plus and OH minus ions in addition to Na plus and Cl minus ions. So this is very important. Whereas in fused Cl, just Na plus and Cl minus ions are present in the solution. But whereas in aqueous solution means here water is there. So in addition to this Na plus and Cl minus ions, which ions are present? H plus and OH minus ions are present. So what is happening? So here how many? Two cations are present, two anions are present. So on passing electric current, what is happening? We will see. So on passing electric current, the H plus and Na plus ions move towards cathode. So when we passes electricity, what happens? Cations will move to the cathode. So here how many cations are there? Two cations, that H plus and Na plus. So these two ions move towards cathode. Similarly, OH minus ions and Cl minus move towards anode. So same two anions are present, that is OH minus ion and Cl minus. And these two ions, what they will do? They will move towards anode. The H plus ions undergoes reduction at cathode, preferential to Na plus ions due to less deposition potential. So among these two H plus and Na plus ions, so which is undergoing reduction? This H plus ions undergoing reduction at cathode, preferential to Na plus ions due to less deposition potential. So this Ha plus ions undergoes reduction. Okay. Similarly, Cl minus undergoes reduction. Similarly, Cl minus undergoes oxidation preferential to OH minus ions at cathode. So what is happening here? So here H plus ions undergoing reduction, here Cl minus ions undergoing reduction. So what happens here? Hydrogen gas will liberate and here chlorine gas will liberate. So H2 and Cl2 are produced at the cathode and anode respectively. The following reactions takes place. So here among these two H plus and Na plus, this H plus ions will takes place. The liberation will takes place. This undergoes reduction. So why means due to less deposition potential. So here also same explanation. So among these two, due to less deposition potential, this Cl minus will undergo oxidation and chlorine gas are formed. So during electrolysis of aqueous NaCl, which are liberating at anode and cathode, which gases? Hydrogen gas is liberated at cathode and chlorine gas is liberated at anode. So whatever the Na plus ions and OH minus ions are there, they will combine and form a sodium hydroxide byproduct in the solution. So at cathode, so what is happening? So both ions are moving, Na plus and 1. So here, this H plus ions are undergoing reduction and form hydrogen gas. At anode, Cl minus and this OH minus ions are going, but these ions are undergoing oxidation and forming chlorine gas. So if you see here, reduction reaction, already I told chlorine reaction. So whatever the Na plus and OH minus ions are present in the solution, they will form a product called as sodium hydroxide as a byproduct. So here hydrogen gas is liberating, here chlorine gas is liberating. So this is about electrolysis of aqueous NaCl. Okay. So what difference you have observed between electrolysis of fused NaCl and aqueous NaCl? In fused NaCl, there just two ions, it is one cation and one anion is present. So what is happening? Sodium is going to the cathode and Cl minus is going to the anode. So there they are undergoing chemical reaction. Sodium metal is deposited at cathode and chlorine gas is liberated at anode. Whereas in aqueous NaCl, what is happening? Here, in addition to Na plus and Cl minus ions, and two more ions are present, that is H plus and OH minus ions. That means two cations are present, two anions are present. So what is happening here? Among Na plus and H plus ions, the H plus ions are undergoing reduction because here due to less deposition potential of sodium, these H plus ions are undergoing reduction and hydrogen gas is liberating at cathode. So whereas at anode among the Cl minus and OH minus ions, same reason here also. Due to less deposition potential of OH minus ions, the Cl minus ions are undergoing oxidation and liberating chlorine gas. So whatever the electrons liberated here, they will float here and come to the cathode. There it undergoes reduction. Same explanation, but here products formed are different. At anode, same there and here, chlorine gas. Whereas at cathode only here, not metal is depositing, hydrogen gas is liberating. So this is about electrolysis of aqueous NaCl. So summary. So what we have discussed in this period, electrolysis of aqueous NaCl. So then we will see the objective type questions. So what type of objective type questions you will expect from this topic in your entrance exam? So very simple questions. First one, the electrolysis of aqueous NaCl produces at anode and cathode respectively. So here options are given: sodium and chlorine, chlorine and sodium, chlorine and H2, H2 and chlorine. So sodium is not depositing, you omit these two, okay? Because when sodium ions are combining with OH minus ions, A and B are wrong. So either C, either D. So chlorine and hydrogen are liberating, but at anode which one is liberating? At cathode which one is liberating? So at anode, chlorine gas. See here. At anode, chlorine gas. At cathode, hydrogen gas. So what are the options? This. At anode, chlorine gas. At cathode, hydrogen gas. So answer is C. Okay. So answer is C. So the electrolysis of aqueous NaCl produces chlorine gas at anode and hydrogen gas at cathode respectively. So come to the next question. Which of the following forms non-conducting aqueous solution? So here some solutions are given. Among the solution which is non-conducting aqueous solution. So A, ethyl alcohol, B, acetic acid, C, magnesium chloride, D, potassium chloride. Okay. So here non-conducting, that means it will not conduct, non-conducting aqueous solution. Okay. So this is also a conducting, this is also a conducting, this is also. So what is the answer? Answer A, ethyl alcohol is a non-conducting aqueous solution. So answer is A. And next come to the third question. On electrolysis of aqueous NaCl, the product formed in the electrolytic cell. So once again I will read the question. On electrolysis of aqueous NaCl, the product formed in the electrolytic cell. So not here is asking at the electrodes, in the electrolytic cell, which is the product forming. So we studied now here. So I didn't write the equation. So we can write here. So products formed here in the, so hydrogen and chlorine gas are liberating at cathode and anode, and remaining ions are Na plus and OH minus are combining to form what are the products? Na plus, Na plus plus Cl minus, Cl minus, these both combines and forms what? Sorry, not Cl minus, OH minus ions. So OH minus ions, OH minus ions, they form a byproduct called as NaOH, NaOH. Okay, this is the product formed in the electrolytic cell. So in this electrolytic cell, you will get this product. So here we will keep this arrow mark. So this is the reaction taking place. Okay. Okay. So Na plus plus OH minus combines this NaOH product. So what is the product formed in the electrolytic cell? Sodium hydroxide is formed in the electrolytic cell. Okay. So he is asking not at the electrode. So in the electrolytes, in the solution, in the electrolyte, in the solution means in the electrolytic cell means both are same. Okay. So what is the product formed with the electrolytic cell? This is sodium hydroxide is formed. So actually I didn't write here. I forgot to write this product. So this is the product formed in the electrolytic cell. Okay, so in objective type questions. Okay. So what is the option here? So Na plus OH minus will combine and form sodium hydroxide. So which one is the option? Answer A is the correct. Okay. The next question. NaOH is prepared by the electrolysis of which among the following? NaOH is prepared by the electrolysis of which among the following? So by doing the electrolysis of among these, any one solution will give NaOH. So A fused NaCl, B aqueous NaCl, C aqueous KCl, fused KCl. So here we are, he is asking about NaOH products. That means you can omit these two options, KCl, fused NaCl. If you do fused KCl or aqueous NaCl electrolysis, you won't get this sodium hydroxide because here sodium. So you can take here. So we studied these two only, no? In the last class, fused NaCl. In today's class, we have studied aqueous. So by doing which electrolysis, by doing which solution electrolysis in this product is formed, just now I discussed, no? So here reverse. This question is by doing electrolysis which product is formed, he is asking. Here what he has given, by doing which solution electrolysis we are getting this product is. So answer is B, aqueous NaCl. That means if you do the electrolysis of aqueous NaCl, you get the product NaOH in the solution. So answer is B. So this type of objective type questions you may expect from this topic in your entrance. Okay, next come to the questions. So what type of questions you will expect from this topic? So only one topic we discussed in this period. So that is same direct question. Explain the electrolysis of aqueous NaCl. So already in the electrolysis of fused NaCl also I told you. So this question, if you get like this question means this is for 5 marks. So if you get for 5 marks, what you have to do? So first you have to explain the construction of the electrolytic cell with this solution. So what you have to explain? So in one beaker, aqueous NaCl solution is taken as electrolyte. In that aqueous NaCl solution, two electrodes are dipped and these two electrodes are connected to the two poles of the battery. Two metal rods, you have to say. Two metal rods are dipped and these two rods are connected to the two poles of the battery. So whatever the rod connected to the positive pole of the battery, that is anode. Whatever the rod connected to the negative pole of the battery, that is cathode. Then on passing electricity, so what is happening? So here what we are taking aqueous NaCl. So aqueous NaCl means in addition to Na plus and Cl minus ions, what are the ions present in the solution? H plus and OH minus ions. That means two cations and two anions are present. So here when you pass electricity onto this aqueous NaCl, so whatever the cations, whatever the anions present in the solution, they will move to the respective electrodes. That means cations will go to the cathode and anions will go to the anode. That here two cations are present, Na plus and H plus ion. These both ions will move to the cathode. Similarly, H plus and OH minus ions will go to the anode. So, but after going to the anode and cathode, only one ion will undergo chemical reaction. Okay. So here that in preferential to this sodium ion, H plus will go undergo reduction and forms hydrogen gas at cathode. Similarly, here Cl minus ion will undergo reduction and forms chlorine gas at anode. Like that you have to describe, and remaining whatever ions present in the solution, that is Na plus and OH minus ions, they will combine and form sodium hydroxide as a byproduct. And you have to write these equations, very important, these equations. At anode, at cathode, reduction takes electrons and forms hydrogen gas. Equations very important. At anode, oxidation. Okay, so 2Cl minus releases 2 electrons and chlorine gas is formed. And you have to at last write this byproduct. So whatever the Na plus and OH minus ions present in the solution, sodium hydroxide is formed as a byproduct in the solution. So like this you have to write the equations. So okay, if you have any doubts, we will clarify your doubts in the next class. So we finished, up till now we finished introduction to electrochemistry. Introduction to electrochemistry. In introduction, we have studied types of substances, types of conductors, types of electrolytes. Then in next class, in second class, we discussed about differences between metallic and non-metallic conductors. Next, Arrhenius theory of electrolytic dissociation. Then next, we studied about electrolysis. What is electrolysis? What is electrolytic cell? That's the construction and working of the electrolytic cell. And next, we discussed electrolysis of fused NaCl. Then today we discussed electrolysis of aqueous NaCl. So okay, we will use whiteboard and I will draw once again. I will draw the diagram. Same as fused NaCl. So here you have to take the, sorry, okay. So this is the beaker. In that beaker, you have to take the electrolytic solution. So which electrolytic solution? Aqueous, NaCl. Then you have to dip the two metal rods. These two metal rods will be connected to the two poles of the battery. So one is connected to the positive pole of the battery, that is called as anode. One is connected to the negative pole of the battery, so this is the negative pole, and this is the positive pole. So this is anode here, anode. This is cathode. This one is cathode. Okay. Okay. So this is the aqueous NaCl. Aqueous NaCl is the electrolyte. So here Na plus Cl minus ions will be present. H plus OH minus ions are present. Both will move to the electrode respective these two ions, Na plus and Cl minus ions will move to this cathode, and this Cl minus and OH minus ions will move to this anode. So in preferential to Na plus ions, this H plus ions will undergo reduction. So here H2 gas is formed. So in preferential to OH minus ions, this Cl minus ions will undergo oxidation. So here chlorine gas is formed. Okay. So whatever the products remaining in the solution, whatever the ions, that is Na plus and Cl OH minus will combine and form a byproduct in the electrolytic solution, that is sodium hydroxide is formed. Okay, so this is the byproduct formed in the electrolytic solution. So like this, you have to neatly draw the diagram and you have to label it. Okay. So with this we finish today electrolysis of aqueous NaCl. If you have any doubts, you will clarify your doubts in the